All right, and welcome to 3.3, the Factor Theorem. We have an exciting lesson for you today. It's not always exciting, but this one's pretty good. Before we get started, I'd like to back up for a second to the previous lesson, the very end of it, which was the remainder theorem. I was looking at this and I realized that this actually says the wrong thing. This says a theorem for today. So really, instead of this, you want to kind of ignore that. It was really the remainder of a polynomial p of x when it's divided by x minus a is equal to p of a, which sounds like a mouthful, but if you recall, like here in our first example here, if you've got p of x is equal to this long polynomial, if you want to know what the remainder is when you divide by x plus 1, you just plug in a -1 and you find out that the answer is 32, and that's the same thing as the remainder. So that's what we did yesterday. So now looking over today, it says the factor theorem tells us whether or not the divisor is a factor of the dividend if there is no remainder. Well, what are factors and things like that? Well, let's remember, if I did something and I said, you know, what's 17 divided by 5? We would get, what, 3 with a remainder of 2. Right? So in other words, you could say, is a 5 a factor of 17? And your answer would be no. And how come? Because the remainder is not 0, right? If this remainder was 0, if it went into it evenly, then we'd be good to go. Well, same thing here now. You'll see that the factor theorem is just sort of like an add-on to the remainder theorem, that if you plug in this value in, and you get a remainder of 0. If you get a remainder of 0, you know that that binomial was a factor. Okay, so let's do an example. Determine whether or not x plus 2 is a factor of f of x equals x cubed minus 6x minus 4. So if we're going to check if x plus 2 is a factor, then our a value will be equal to -2. Right, because it's in that x minus a format. So I will plug in, and I'll use f of -2 is going to be equal to -2 cubed minus 6 times -2 minus 4. So everywhere in here where I saw an x, I replaced it with a -2. -2 cubed is -8. -6 times -2 is plus 12, and then minus 4. So what does that add up to? It adds up to 0. Yay! So the answer is yes. It is a factor. Determine whether or not we did it. Okay? Now look at the cool stuff we're going to learn how to do. We're going to learn how to completely factor this x cubed minus 7x plus 6. We're so used to, stopping at the quadratic of doing x squares and not going past that. Well, we're gonna move beyond that today. So if it's an x cubed, I guess like the best outcome, depending on how easily it is to factor, but the best outcome we could get would be to have 3 terms kind of looking like this, right? If we only had the 2, like if I didn't do a third one, that could make an x squared something. But maybe we have enough to do 3. Like it might not look that good. Maybe we can't factor it completely. Maybe we'll get an x here and then something with an x squared. We'll see how it goes. Okay, so we're going to first find the factors of x cubed minus 7x plus 6, and we're going to use the remainder theorem. So, I don't know. I guess we just kind of have to guess here. So, why don't we do something systematically? I'm going to start off and say, is x minus 1 a factor? I'm going to ask that question. So if x minus 1 is a factor here, I'll keep track of the ones I'm doing. I'm working on x minus 1. That means my a value will be 1. So I will use p of 1 is equal to, so keeping an eye over here, I'll put a 1 cubed minus 7 times 1 plus 6. I like to start with the x minus 1 because it's so easy to do. 1 minus 7 plus 6 equals 0. Cha-ching, we found one already. So we have an x minus 1. Okay, so now, I don't know, how about x plus 1? So now my a value is minus 1. So I'll say p of minus 1 is going to be equal to minus 1 cubed minus 7 times -1 plus 6. Now if I have a negative to an odd power, or odd exponent, I guess, then it's still negative. Now this will be plus 7, plus 6. Now I don't actually have to figure out what the answer is. All I have to do is think about, is it equal to 0 or not? Not, okay? X minus 2, let's try that one. So I'll be plugging in a 2. P of 2 is going to be equal to 2 cubed minus 7 times 2 plus 6. So here I get, what, an 8 minus 14 plus 6. Hey, that looks pretty good. 14 minus 14, so I get a 0. So here is my second answer. Let's go on to x plus 2. Now I get a p of minus 2 equals minus 2 cubed minus 7 times minus 2 plus 6. So what do I get here? A minus 8 plus 14 plus 6. No, that one is definitely not 0. Well, what about x minus 3? So I have a p of 3. So I get a 3 cubed minus 7 times 3 plus 6. 3 cubed is 27 minus 21 plus 6. No, that's definitely positive, so it's not 0. Okay, I'm doing lots of work here, and I got a little bit left to do. I'll try the x plus 3. So I get p of minus 3. I plug in the minus 3. I get negative 3 cubed minus 7 times negative 3 plus 6. So I'll get a negative 27 plus 21 plus 6. Hey, check it out. That works out to 0. So I have my three answers. I have x minus 1, x minus 2, and x plus 3. And so, hey, let's fill this in over here. I've got x minus 1, x, what was the other one? X minus 2, and x plus 3. And so there is my answer. That is pretty cool. If I go over here, I'll say, at the bottom it says, there must be an easier way than randomly guessing infinitely many times. Like I just started from -1 and worked upwards. And, thankfully I hit the thing. But what if I had just tried like x plus 28 or x minus 26 and tried things out? Maybe there's a method to that would speed things up a bit. Well, here comes the integral zero theorem. And I want you to, let's just back up for a second. If you'll notice something, these are all x's. X times x times x. That's where the x cubed comes from, right? I was able to sort of think about that ahead of time. Check out -1 times -2 times +3 is equal to +6. So these ones here are going to multiply out to my constant term. Let's look at the next example here. Here's an example. -1 multiplied by, here maybe I need a highlighter, it might be better. -1 multiplied by +2 multiplied by -5 gives me +10. So by making that observation, we're able to say, hey, whatever the constant is, like here's our example, whatever the constant is, the factors are going to be, all these are going to be factors of that constant. So what are the factors of 8? The factors of 8 are plus or minus 1, plus or minus 2, not 3, but plus or minus 4, and then all the way up to plus or minus 8. Okay, so we've reduced it from an infinite number of possibilities to 8 possibilities. Let's go back and read this other stuff here. It says the factors of the polynomial are x minus 1, x plus 2. The zeros of the polynomial. So what does that mean, the zeros? Well, if I equate this to 0, then when will this entire polynomial be equal to 0? When x equals 1, because this one becomes a 0. When x is minus 2, because that one becomes a 0. And when x is equal to 5. So those are the zeros, okay? Also, zeros would be if I were to graph it. If I were to graph this function, instead of saying a 0 here, if I was to say y is equal to, then this is the place where I would get a 0 for y, because if I create a 0 anywhere, regardless of my x value, my y will be 0. So this 1, oh sorry, that might be -2, and then the 1, and then the 5 those would be places where it crosses the x-axis. Okay, and so the function might look something like, you know, right? We kind of know from our last lesson if it's cubic and the leading coefficient is positive, it's going to be going up in quadrant number 1 and going down in quadrant number 3. And hey, we also know that it's going to have a y-intercept of 10, so here it crosses a 10, so we know quite a bit about that graph because we're able to factor it. Isn't this cool? All right, so exercise 1 here, now that we're doing the factor theorem, or not just the factor theorem, now that we're doing the integral zero theorem, let's find completely factor the polynomial. This is exciting. We can factor another cubic one. So let's start off with, you might think x plus 1 would be the easiest, but x minus 1 is the easiest because then we get to plug in a positive 1 inside, right? Because the a value is 1. Really, all I need to do is look at the coefficients. So 1 minus 3 minus 6 plus 8. Because x cubed, x squared, or x is always equal to 1. So what does that work out? Hey, we got our first one. That's equal to 0. So that works. Now, another shortcut. The first shortcut we just learned was only look at the factors of that constant. The second one we have now that we know that x minus 1 is a factor, let's divide it in. Let's use synthetic division. I cannot spell. Once again, eraser, division. Okay. So now when we do synthetic division, it's kind of set up already. If x minus 1 is what we're dividing into, it again is that x minus a format. So it's this thing that we're going to use for synthetic division, so that when we set up our L over here, we put this 1. Okay, so that's the same thing. And what are we dividing by? We're dividing by x minus 1. So over here I'm looking at this in synthetic form. I just put the coefficients 1 minus 3 minus 6 and plus 8. And remember, this just drops down. 1 times 1 is 1. Negative 3 plus 1 is negative 2. Times 1 is negative 2. So here I get a negative 8. The negative 8 comes up there and I get a 0. Now, if you've already found out this was a remainder 0, this should be the same. This is kind of like a check here. If you get a 0 here but not a 0, then you should look for a mistake because you made a mistake somewhere, but you just have to figure out where. Okay, so now what happens when I divide it out? I get, here's my quotient, x squared minus 2x minus 8. Okay, so how do you factor just one of these regular kind of quadratics? Well, I think I need two numbers. It's going to look like this. And I need two numbers to put here and here that have a product of negative 8 and a sum of negative 2. What sum, not sun, what could that possibly be? Well, I would say, what, negative 4 and positive 2. So I'll put a positive 2 here, negative 4 there. Let's see, they multiply out to negative 8, they add up to negative 2. Sounds good. So then my final answer would be, if to factor it completely, don't forget my x minus 1, right? So I have three factors. It is, well, let's write it all out. F of x is equal to x cubed minus 3x squared minus 6x plus 8. So that would be equal to my x minus 1 times x plus 2 times x minus 4. All right. They don't ask us to, but let's say, what are the zeros? The zeros would be 1 from this one, negative 2, and plus 4. Now, just for fun's sake, I want you to think about what this is going to look like if we graphed it. Okay, so it's cubic, it's a positive leading coefficient, and these are the zeros. So we'll get a plus 4 over here. It's one of the zeros. Here's a plus 1. Here's a minus 2. And so we also have a y-intercept of plus 8. So we're going to have something that goes like this. Okay, and like that. Heck, let's just go check it out. I think I've got this loaded in here at Desmos. So there it is. We got this x cubed minus 3x squared minus 6x plus 8, and that is exactly how it looks. Isn't that neat how far we've come so quickly using the tools of our pre-calculus course? And we have, two more examples left altogether, so let's do them together, shall we? It says, determine all the possible zeros of the polynomial. Okay, so all the possible zeros, let's see here. What are all the factors of 12? It's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. There's a lot to go through there. Luckily, we're going to use that same shortcut. So as soon as we find one that works, we're going to use synthetic division, and then we will turn that cubic function into a quadratic function, and then hopefully it'll be faster. So I don't know, I like to start with x minus 1, so we'll put x minus 1. So we'll find f of 1. So this will be negative 2 plus 3 plus 8 minus 12, which does not equal 0. I've got 14 negative and only 11 positive, so that's not equal to 0. I can rule that one out. Let's try x plus 1, in which case I'll be f of negative 1. So I'll get negative 2 times negative 1 cubed plus 3 times negative 1 squared plus 8 times negative 1 minus 12. Let's see. This will be negative times 2. Negative 2 is positive 2. That'll be a plus 3 minus 8 minus 12. I got a lot of negatives, not very many positives there. Okay, let's try x minus 2. So it is f of 2. So I will get, I just need to be able to see my original function there, negative 2 times 2 cubed plus 3 times 2 squared plus 8 times 2 minus 12. Okay, so minus 16 plus 12 plus, hey, I'm getting excited. Look at this. I've got these minuses cancel each other out and the 12s cancel each other out. Oh, it's fantastic. So I get a 0 here. So I'm so happy because now I know one of them. So I can bring up my synthetic division, right? So I can bring out synthetic division and say I will be doing a 2 here. And what was it again? It was, just get it all on the screen at the same time. It's a negative 2, and then a 3, and then an 8, and a minus 12. When I'm looking at this, I'm thinking, is it descending? X cubed, x squared, x, yes. Are there any holes? Do I need to add a 0? No, it's kind of an easy one that way. Alright, so if I did things properly, I should get a 0 over here. I'm going to put that ahead just in anticipation. So I get a negative 2 here. Negative 2 times 2 is negative 4. This gives me a negative 1. A negative 2 goes up over there. So now I get a 6. 2 times 6 is 12. And can you sense the excitement? Yes, we did get a 0 there. Okay, so once we divide out that x minus 2, now I have minus 2x squared minus x plus 6. And I need to factor this. Okay, so I hope you guys remember how to do this. If you need to, I do have a little practice sheet on these type of things because it's a quadratic term, but where my a value, remember we ax squared plus bx plus c, this is not just 1, it's a minus 2. So what I'm doing is I'm going to look at the minus 2 and the 6. I'm going to say that is, it gives me a product of minus 12. So I want to find two numbers whose product is equal to negative 12. And looking over here, I want two numbers whose sum is equal to negative 1. Alright, so what two numbers would work? I think negative 4 and positive 3 would work, yeah. And so what I do is this, the linear term, the term that just has the x, I'm going to break into two terms. So I'll rewrite minus 2x squared. Now instead of minus x, I'm going to write minus 4x plus 3x plus 6. So you see what happened? This turned into these two. And mathematically it's fine because minus 4x plus 3x is a minus x. Now I'm grouping. I'm going to group the first two terms together. So looking at these first two terms, I'm going to factor out whatever is common. What's common is a minus 2x. So now I get x plus 2. Do you get that? Now looking at these last two terms, what's common is a 3, so I factor out 3 and I get a x plus 2. You know you've done it right when these two are identical. Sometimes you got to watch your positives and your negatives a little bit just to make sure that it works. Okay, so now my last step is factor out that common x plus 2, or different people like to write it different ways. I like to write the minus 2x plus 3 part first, and then the x plus 2 part. Okay, so what we've done is we've taken this here and we've factored it into that. So we have been successful. So it's time to answer the big question here. And please don't forget we still have that x minus 2. So when we say what the answer is, it is x minus 2 times these ones. I'll put the x plus 2 afterwards, and then the minus 2x plus 3. Okay, so now let's just make sure we're answering the right question. It says factor the polynomial, but they want us to determine the possible zeros, right? So what are the possible zeros here? The zeros are, this 0 would be 2. This 0 is negative 2. This 0, well, let's think. When is 2x plus 3 equal to 0? So if we solve for x, so x is equal to 3 over 2. So when is this equal to 0? When x is 3 over 2. And so that is our answer. The zeros are 2, negative 2, and then 3 halves. All right, are you ready? This is our very last question coming up. I know we've done a lot of questions. Can I hand this one over to you guys? I know it's an x to the 4th, so it's a little bit crazy. But I'm going to say this is your turn here if you're ready and willing to give it a shot. If you're ready to jump in the deep end here on this one. If not, you can always cheat and just play it for a little while. So I'd like you to hit pause and give it a shot. See if you can get through this. And then I will, and you know what, instead of just revealing it all, I'll just solve it for you so that you can watch me step by step, because you might get kind of lost otherwise. Alright, I haven't finished, but I've gotten a good start to it. So the first part is a little depressing. We're looking at 72. Oh my goodness, look at all those possible factors there. The plus or minus 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36, 72. It's kind of crazy looking, and I hope I don't go on forever on this one page just trying to find these things out. So I started off like I usually did with negative 1. Did not work. I tried with positive 1, did not work, and then I tried with negative 2, and it did work, and I was so happy. So then I did the synthetic division, and I was also happy that the check worked, because I got a 0 again. And now I'm going to show you, the reason why I stopped now is, I'm going to try x minus 2 again, okay? Because there may be two identical x minus 2's in there, like you might have x minus 2 times x minus 2, so I'm just going to try it again. So now it's going to be with this. After I did synthetic division, once I've divided my longer polynomial by x minus 2, this is my first quotient here. So now I'm going to say this is going to be p of 2, and so it'll be 2 cubed minus 4 times 2 squared minus 9 times 2 plus 36. And I think I get, what is this? Is this 8? Minus 16 minus 18 plus 36. No, that's going to be 10. It won't be 0. Okay, I'll hit, if you want to hit pause here and then work ahead a little bit again, if you're at this spot, I'm going to go ahead and do a bit more. Okay, so I've carried on now, and notice I'm using my smaller polynomial. I'm not using my original one anymore. Here's the original one, is x to the 4th and all that, because so far I've divided out an x minus 2. So after I divided out, this is my quotient, x cubed and so on. And so for all the rest of my checks, that's the one I'm looking at. And I found out it does work for x minus 3, because when I plug a 3 in, I get a 0. Okay, so that means now I'm going to use this one and do my synthetic division. So when I do my synthetic division, using those coefficients of 1, minus 4, minus 9, and 36, my a value here is 3. So I get and it works out, so I get a 0 here. So now I have x squared minus x minus 12. So I want two numbers who multiply out to negative 12 and add up to negative 1. So I'm thinking that an x plus 3, x minus 4 does it. Okay, so now let's put it all together. So my final answer is going to be, what was my first one? X minus 2, and then an x minus 3, and then an x plus 3, and then an x minus 4. Oh boy, that was a long one, but we did it, didn't we? Okay, so we got it all done. And that is your homework here. So we've got to put together this using the remainder theorem and also doing a lot of synthetic division. But it is pretty exciting that you can start off with an x to the fourth and having this huge polynomial. And we did it. We factored it all. So that's great. Why does it help to factor it? Well, for one thing, it really helps. It makes it very easy to graph afterwards. Okay, so thank you very much, and we'll see you in class.